Well, hi guys. Remember earlier when we had this constellation, this circuit, and we had a 9-volt battery over a 1 kilo ohm resistor, and we had a 1.5 battery over a 1 kilo ohm resistor. I built in here 1K resistor just to be sure, and nothing is here shorted. And I really made a big video about it, but I think with Kirchoff's voltage law we can analyze the circuit even easier, and that's what we're going to do now. So using Kirchoff's voltage law, so the battery has here plus and here minus, this battery 1.5 volt has here plus and here minus, and so from this point of view here, the voltage drop across this 1K resistor, we say that is here positive, here negative. It's just you can do it arbitrary. You could also do plus and minus otherwise, but you have to then use it in that way in the further steps. So going from here, from the 9 volt to over this 1K resistor, which has the opposite direction, we are having the first mesh here. So let's call this voltage here over the 1K resistor, let's call it UR. Okay, so we say back our 9 volts positive and then minus UR equals 0. That's always equals 0 is always the standard thing to do in Kirchoff's voltage law. And because we go from plus here, but this plus minus is opposite to this plus minus, so we have to take it negative, this UR. And then watching the other mesh here, we go from here, we take that as a positive in this direction, so UR, then this 1.5 volts is against our direction, minus 1.5 volts, and then for this resistor, we do the direction like this, plus minus, and then this is in the direction of our loop, because our loop goes this way. Then we have minus 1.5, and we call that UR2, and then we have plus UR2 equals 0. Okay, from these two equations we can already, let's call this the first equation and this the second equation. From this first equation we can also already derive that UR equals 9 volt. So over here we have 9 volt from here to here. And then next thing is, if we now put this here, this result into the second equation, then second equation looks like UR, so this is now 9 volt UR, we can plug in 9 volt. 9 volt minus 1.5 volt plus UR2 equals 0. And we can then solve for UR2, because this here is just 7.5 volt. And then we get UR2 equals negative 7.5 volt. And that's really, that's indicating that the direction we thought of here from plus to minus is wrong, and that the direction really is here, that there is a 7.4 volt drop from here to here. So here more positive and here more negative. So the opposite direction than we thought of. And so, okay, we know now everything of this circuit. The first thing we know is that that this drop here is 9 volt. We got it immediately from the first mesh loop. We thought of this a lot in the last video, so that's eliminated that thinking. And in the second loop, we have calculated that we have a 7.5 volt drop from here to here. And now that's all we wanted. And the last video took us half an hour, and this one is now running for not 5 minutes. But we can finish this even more cool off by then looking at the currents. So the current through here, so there's 9 volt here over a 1K resistor. So let's call this IR. So IR equals 9 volt over a 1K resistor, that is 9 millivolt. So IR is 9 millivolt in that direction. Coming in here, 9 millivolt. And then let's call IR2. IR2, what is that? It's 7.5 volt. 7.5 volt over also a 1K resistor. That is 7.5 millivolt then. 7.5 millivolt going this direction. 7.5 millivolt. And then they sum up. That is Kirchoff's current law. So this video is really touching both. Kirchoff's current law now, KCL. And that says also what currents are going into a point or coming out of the point. So 7.5 and 9, they're going in the same direction in. So must come out and sum each other up. So there comes 16.5 milliampere. Oh, sorry, milliampere. Always one mistake is always baked in my videos. I hope you found it earlier. And so there are coming 16.5 milliampere out here. And that and if they come out here, then of course they go in above here also the 16.5 milliampere. Yeah, and that's the whole circuit in around 5-6 minutes, which we did a half an hour last time. Thank you for watching, and always watch out for Kirchoff's voltage law and Kirchoff's current law. See you next time. Bye-bye.